I'm Taylor Kenion.
I'm John Paul Cantonwine.
I'm Drew Govert.
And I'm David Ward.
And we are Team PL1. We participated in FEDD in fall of 2018 with our project named Nerf or Nothing. One of the most important parts when overcoming an engineering task is to implement the engineering design cycle, which consists of 5 straightforward steps. Ask, imagine, plan, create, and improve. Although this cycle seems to have a set order, it's important to realize that one will most likely have to refer to several of the steps out of order, and that the design cycle is a continuous process as everything has the ability to be improved. Through the use of a combination of these steps, our team was able to effectively face the challenge of designing a precision launcher capable of consistently launching 30 feet.
We had a few guidelines and rules we needed to follow in the construction of our launcher. The projectile needed to be made of a foam-like material, and it could be no more than 5 inches in diameter and no less than half an inch in diameter. The launcher had to be constructed with any materials that we could find, but it had to fit within an imaginary 4-foot cube box. The distance to the target was measured from the front edge of this box. The launcher had to be placed on the floor. The weight that we were using to launch the ball could be attached using any method. The only human intervention allowed was the loading and release of the weight. The launcher needed to involve at least 2 methods of energy transfer, and the launcher needed to be able to be loaded and fired in less than 30 seconds. The target was 30 feet away and was positioned vertically and angled slightly. The bottom edge touched the floor, and the target had concentric circles with the following diameters and point values. The center circle was 6 inches in diameter and gave us 100 points. The second ring was 12 inches in diameter and gave us 50 points. The third ring was 24 inches in diameter and gave 25 points, and the outer ring had a diameter of 48 inches and gave 5 points.
One of our requirements was to create a research paper describing the following topics. The first one being Principles of Aerodynamics, which included research on the shape and size, the weight, thrust, drag, and lift associated with the projectile. Next was the various properties of a slingshot, zero energy state, and energy transfers used in our launcher. For the Imagine portion of our project, we drew up concept drawings for what it could possibly look like. The first image shows the launching mechanism that we designed for the launcher. The second image shows the setup for the launcher as a whole.
After we created concepts of our launcher, we needed to figure out how it would work realistically. We drew plans of our launcher on a whiteboard, showing how the pulley system and elastic would work together to shoot the projectile after it was loaded. However, we ended up ditching these pulleys and using a hose clamp instead. Next, we drew how our launcher's base and projectile holder would look. The top drawing is a look at the inside of the barrel of the launcher. Finally, we drew plans of the loading mechanism with pulleys. The pulleys and weight would load the ball back and prepare it for launch.
After discussing a multitude of designs and ideas, it was time to begin constructing our launcher. Using a drill and a miter saw, as well as a couple of weekends, we were able to construct our launcher from several 2x4 cuts of wood and a 2-inch diameter PVC pipe. Construction began with a sturdy base designed to limit energy loss due to the dropping 5-pound weight. Next, 2 A-frame-like pieces were attached in order to provide a place for our launching mechanism to be mounted. Originally, our plan was to mount 2 pulleys in front of the launcher. However, during construction, we realized that it wasn't practical. Before mounting the launcher, we devised a rail system using a cylindrical piece of metal and a modified water bottle cap which would consistently guide a projectile out of the tube without much loss due to friction between the rail and the cap. We attached our elastic to the water bottle cap and finally mounted the rail into the tube and the tube on the base to complete the construction of our design.
We began testing our launcher, and we had a problem trying to figure out how to disconnect the weight from the slingshot once it had pulled it all the way back. In the end, we found a way to tie our weight using a modified highwayman's knot so that it would release once it brought the ball back. When we first started testing, our launches were inconsistent because the range heavily depended on the way that the knot was tied. But once we figured out how to tie the knot consistently, we became more successful. Tests showed that our launcher could easily hit the target from 20 feet. Even though it was not the maximum range of 30 feet, we were pretty excited, at least until our testing session the night before FEDD, where the elastic broke. We had to quickly install a new piece into the launcher to continue testing. Overall, it was probably a blessing in disguise because we had an excuse to put a fresh piece of elastic onto the launcher before the competition.
Our group participated in the morning session on FEDD Day. Overall, we placed second out of the 15 other teams in the precision launcher competition with a total score of 50 points.
If we could do anything over, we would focus on different projectile types, elastics, and knots. A denser ball could have helped us get more range, a thicker elastic would have been more powerful and dependable, and an efficient knot would have helped our weight drop be more consistent.
Some advice to incoming freshmen may include, first, to plan ahead. It's important to expect there to be problems and to be prepared to fix them. Second, allow sufficient time for testing. Testing the weekend before is not a good idea and can prove extremely stressful if something fails or doesn't work like you expected. 3. Use your team efficiently. Divide up work and use every team member's skills effectively. 4th, make and meet deadlines to stay on schedule. And finally, follow the rules. Several teams were disqualified even though their launchers worked really well due to the fact that they failed to follow the rules.